Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Calculate the overall yield for part A. The reaction sequence has 3 steps with yields of 58%, 54%, and 68% respectively. Overall yield is equal to 0.58 times 0.54 times 0.68 is equal to 0.58 times 0.3672 is equal to 0.2130. 21%. This matches option C, 21%. And for the final step, identify reagents A, B, C. For part B, reaction A, Me3C, C is equal to O, CH3 Me3C, C is equal to O, CH2Br. This is alpha bromination of a ketone. Under acidic conditions, Br2H plus brominate the alpha carbon of the ketone selectively. This rules out NBS, which is used for allylic benzylic bromination, and Br2O, which would give multiple brominations under basic conditions for methyl ketones via haloform reaction. So A is equal to Br2H plus. Reaction B, Me3C, C is equal to O, CH2Br Me3C, CH of CH2Br. This is reduction of the ketone carbonyl to an alcohol without affecting the CBr bond. NaBH4 is a mild reducing agent that selectively reduces ketones aldehydes but does not reduce alkyl halides. Lyl4 would also reduce the ketone but is much more reactive and could cause side reactions. However, for selectivity in this context, NaBH4 is the standard choice. So B is equal to NaBH4. Reaction C, Me3C, CH of CH2Br Me3C, CH, CH2 epoxide. This is intramolecular SN to cyclization of the bromohydrin to form an epoxide under basic conditions. The hydroxide O deprotonates the alcohol to form an alkoxide, which then displaces the adjacent bromide intramolecularly to form the epoxide. So C is equal to O. Therefore A is equal to Br2H plus, B is equal to NaBH4, C is equal to O, which corresponds to option B. Why other options fail for B? A. Br2H plus, Lyl4, H plus Lyl4 could work for reduction but H plus would not form an epoxide from a bromohydrin. C. NBS, UlCl3. O. NBS is for allylic benzylic bromination, not alpha carbonyl bromination. UlCl3 is a Lewis acid, not a reductant. D. Br2O, BF3. O. Br2O would cause haloform reaction on the methyl ketone. BF3 is a Lewis acid, not a reductant. Therefore, the correct answer is A, C, B, B. Therefore, the correct matching is A matches C, B matches B.